Good afternoon. For once in my life, I'm actually going to start 30 seconds early. That was not intentional. It's completely accidental. I never mean to arrive early. The slides, however, are fresh. I finished working on them just a couple of minutes ago. The pixels are ready to go. And I think all photographs in this, except for the ones which with copyright messages, are mine. This is from my local supermarket, which is a 25-minute walk away. Should you be interested in going to a supermarket that is actually not the closest supermarket, there is a closer one here. Good afternoon. So I'm going to send you fast asleep with some code. Now, I think this was originally subtitled, when I submitted it, Refactoring-Driven Development. And that was kind of riffing off a phrase from a friend of mine, Rolly Pereira, who I'll mention again in a bit, because he did a really interesting, very informal little talk walking through this. And I had misremembered what he had subtitled it. So I thought, refactoring-driven development. And actually, although he does use the term driven at various points, it's not really driven. It's much more oriented. And then I also recognised that he used the term software engineering, and it was after I had submitted the talk that I suddenly thought, oh my goodness, refactoring-oriented software engineering, that spells Rose. How perfect is that? So, never one to walk away from a coincidence. I fully embraced it. Let me think. I wasn't here last year. I hope it was good. I hope today's been good. This year I haven't got COVID. That's an improvement on last year. But I have got a lot more social contact details because strange things have been happening at Twitter, so you can't really count on it. Anyway, stuff, you can find me. I'll also be at the lightning talks this evening and at the drinks afterwards, and then you'll be able to find me under a table. So a quick show of hands. Who has heard of the Gilded Rose Kata? So a handful of you. Who has done the Gilded Rose Kata? Okay. Right, okay, so a couple of you. So I had anticipated that would be the case. So I'm going to go through this one relatively slowly. I'm not, this is, I will point, if you want to actually do the Kata yourself, this is not really the time, but I will give you the resources to do that. It's relatively well known, but that's always relative to a particular space of people. So for me, I think I came across it, I would say 5 years ago, but I've learned to add 2 for the pandemic, so it is about 7 years ago. 2016 sounds about right. I'd call it the pandemic offset. Whenever you were trying to recall something, that was 5 years ago. No, 7. Yeah, it was 3 years ago. No, it's 5. Yeah, that kind of thing. So I'm just trying to work out what that means for my age, but let's not go there. So about 2016, I heard of it, and I heard of it from Emily Batch, who's done a lot of really good stuff on coding katas, a lot of really good stuff on approval testing, and really kind of improving craft. And I'm pretty sure I heard about it through her. But I also started noticing, in that kind of way that you do, you suddenly notice it popping up on blogs or mentions of it here and there on Twitter. So I ended up being directed to a number of different resources, and I ended up using it, actually. I didn't get around to actually doing it properly. I was aware of it. I didn't get around to doing it properly until, the pandemic gives us lots of time. But I've started using it as a teaching exercise because it is exactly what it purports to be, a really interesting refactoring exercise, or refactoring and testing and development. In fact, it's a kind of slightly more holistic one. And what's nice about that is that rather than building something from scratch, you're given something. Now, that nice was in quotes. We'll come to look at it in a bit. You want me to stay in this? Oh, that's really hopeful and optimistic. That's just not going to happen. I'm sorry. It's more, the whole quantum mechanics things. Is the particle in the box or is it out of the box? And it's a bit like that. I mean, I will try, but this is how I get my steps in. So there was a talk that Sandy Metz gave at RailsConf in 2014 that everybody directed me to, but I made sure I didn't read anybody else's version before I did it, and I wanted to see where I went with it. And there's her version, and I've seen a couple of others. In fact, I was in Amsterdam last week at KotlinConf, and a really nice demonstration by Dmitry Kalendov of kind of IntelliJ refactoring tools. He'd managed to do everything through automated refactorings. I'm going to take exactly the opposite approach, or rather, I'm not going to go into the detail of the refactorings. I don't care the mechanics of it. I think sometimes people get too wrapped up in refactoring. Oh, that's tools. I think that's great. I don't have a problem with it. But what I have learned is people don't know what they should be refactoring. That it turns out that the tools were never the problem. Has anybody had experience of legacy code? Right, it's 2023. Automated refactoring has been around for over 20 years in a commercial sense. It's not the tool, okay? We have 20 years of evidence that tells us it was never the tool. It was the mindset. The tools help those with the mindset, and they help to give some people the mindset. But sadly, they are in a tiny minority, it turns out. Most people look at a refactoring tool as rename. Or they're in C++ and they go, what the hell's refactoring? But I was interested. I started thinking, how old is this thing? Because it keeps kind of coming back in waves. How old is this thing? So clearly, it's older than 2014, because Sandy Metz did her talk in 2014. And although I heard about it from Emily Batch, it didn't come from Emily Batch. So I did a bit, it was just a case of the information's all out there. It's actually a guy called Terry Hughes. And so here's his tweet in 2013. He did it as just a kind of a simple coding kata, obviously. Blows my mind how popular the Gilded Rose kata is. Obviously, that's within particular circles. And not myself, that's Bobby Johnson for exposing it to the world. Also, laugh every time I read the setup. You will laugh as well. No talk is complete these days without ChatGPT. Because I was struggling to find out how old this. I really care about origin stories for things. How old is this thing? It's older than 2013, or it's as old as 2013. So I thought I would go and ask ChatGPT, because my Google foo was failing me. When did Terry Hughes create the Gilded Rose kata? Terry Hughes did not create the Gilded Rose kata. Oh, the Gilded Rose kata is a coding exercise that was originally created by Emily Batch in 2011. Let me just say that this was the second time I asked ChatGPT. First time, it said 2009. It's like it's just making stuff up. It's a people-pleasing, sociopathic savant, okay? And in Emily's book, okay, on the Coding Dojo Handbook, she's got a handbook all about running coding dojos for TDD, refactoring, and so on. She actually specifically says, with thanks to Terry Hughes, who originally designed the kata for permission to include it here, but clearly she was wrong, because ChatGPT told me the truth. Anyway, let's walk through the setup. Hi, welcome to Team Gilded Rose, it starts. As you know, we are a small inn with a prime location in a prominent city run by a friendly innkeeper named Alison. So tense differences are also, we'll come back to tense differences in a bit, so I've kept the original. I kind of always wondered, the Gilded Rose, what is that? Turns out it's something from World of Warcraft. This is it, okay? This is the inn, okay? So there's lots of references to World of Warcraft, I believe. Never played it, have no real desire to. Some really interesting architecture. In fact, the most interesting thing about World of Warcraft for me was the back-end architecture. I attended a talk on it a number of years ago. Lots of scary C++. Okay, so we also buy and sell only the finest goods. Unfortunately, our goods are constantly degrading in quality as they approach their sell-by date. We have a system in place that updates our inventory for us. It was developed by a no-nonsense type named Leroy, who has moved on to new adventures. Oh, yes, we know what this means. This is code for legacy. Yeah, when somebody says, oh, they moved on. Yeah, okay. We don't care if it was to another realm or plane of existence or another company. This is legacy. Now, interestingly, because as I said, I'm interested in the origin of things, the term legacy has only been in use since 1989 in this context. This is the earliest citation from the OED. It's not that we didn't have it before, but people just didn't really have a name and didn't really think of it as a problem. And then it's just like, oh, now we know. We have a lot of experience in this. Your task is to add new feature to our system so that we can begin selling a new category of items. Oh, you've been invited in. Yeah, we all know how this one works out. Okay, so an introduction to the system. All items have a sell-in value, which denotes the number of days we have to sell the item. All items have a quality value, which denotes how valuable the item is. At the end of each day, our system lowers both values for every item. Pretty simple, right? Oh, this is where it gets interesting. Once the sell-by date has passed, quality degrades twice as fast. The quality of an item is never negative. Okay. So in your head, you're putting all this stuff, yeah, okay. Aged brie actually increases in quality the older it gets. Excellent. The quality of an item is never more than 50. Okay? This sounds like somebody trying to adopt some kind of crazy metrics-driven approach to quality. It's like maybe it's safe or something like that. Anyway, so these are the constraints. No, they're not. There's more. Sulfurous, being a legendary item, never has to be sold or decrease in quality. And backstage passes, like aged brie, increases in quality as its sell and value approaches. Quality increases by 2 when there are 10 days or less, by 3 when there are 5 days or less, but quality drops to 0 after the concert. Okay, that makes sense. Okay, now, requirements. We've recently signed a supplier of conjured items. This requires an update to our system. Conjured items degrade in quality twice as fast as normal items. Okay. Actually, it was wrong. This is where it gets interesting. That's the code. Look at that formation. You know, that's kind of like migration patterns of geese. Now, this is C#. That's the original language in which the Kata was done. I have kept the original code. There is one thing that I have changed. You will find that this Kata has been done in a number of different languages. In training, I have primarily used this, in training workshops, I primarily use this in C#, C++, and in Python. If you want, you can go and find loads. In fact, let us refer to Emily Batch's location on GitHub. If you want to do it in COBOL, you go for it. If you want to embrace legacy with legacy, absolutely. You know, there's stuff here, you know. There's plenty. There we go. So, I missed the fact there was even XSLT. You know, knock yourself out, okay? Just so you know, that's a really good starting point there. So you can get an easy starting point. So anyway, what we learn from this, we look at that, and okay, you're at the back, you can't see the code. You're at the front, you can't see the code either. So that's fine. The point here is this is what you need to know about this. Okay, classic legacy system. Okay, we don't know who built it. We don't know why they built it. It lines up a couple of times a year, seems to work. Really not sure how to change things. Now, when people talk about this stuff, they tend to use the language of technical debt. I'm not going to say that it is necessarily incorrect that people do that, but that is not the motivation for the original technical debt metaphor. What people really have a problem with is unmanaged technical debt. Technical debt's just fine. Or rather, it's not necessarily bad. It's not fine. It's not necessarily bad. Debt intrinsically is not necessarily bad. It's just the nature of the debt. And people often say, oh, we've got a lot of technical debt. Okay, but what's your problem? I just told you my problem. Is it unmanaged or managed technical debt? If it's unmanaged, that's a problem. If it's totally under control. We have tickets for everything and we have a policy whereby we make sure we address certain technical debt items on a regular basis, you do not have a problem. Okay? In fact, you can become a consultant. Okay? That might itself be a problem, but the world is full of those. But the point here is that we are focusing on the wrong thing. A lot of people tend to focus on the debt, which is the effect. Honestly, if you're trying to solve a problem, you need to focus on the cause. If unmanaged technical debt is your problem, technical debt is not your problem. Technical neglect is your problem. That's the cause. Okay, people keep focusing on the wrong thing. It's like a magician, except we don't actually have a magician here, except the system. Okay, it's just like, yeah, how did we get all of this? Oh, we've got to address it. Yeah, but what if we keep making more while we're addressing it? I get lots of teams asking me about, yeah, what do we do about, all our legacy code and stuff like that? Well, how do you produce legacy code? Everybody's so busy trying to work out how to fix it, they haven't stopped creating it at the same time. At best, you'll end up in steady state. You've got to kind of do a causal analysis here. So anyway, technical neglect gives us this, which is, pretty in one sense. One of the bits I want to zoom in on, all the action happens in this method, the update quality method. You'll notice some gems here, like public data. I mean, the fact that it's iList is almost worthless. A slight nod to sort of reducing practices via using an interface, reducing dependencies, it's almost worthless because it's public, it's assignable. Then we've got this, which it's a real habit of a lot of C# programmers of just saying, yeah, I've got an object, it's totally encapsulated, I've got properties, and I'm going to make them auto properties, which basically is exactly the same as having a public field, just more syntax, and gives you kind of like a slight feel-good factor, okay? Okay, it's just a very popular practice. Just out of interest, people who do C#, just I need to know, a bit of translations, a couple of you. Don't worry, C++, I presume, is dominant. Give me your hands. Yep, okay. It's kind of the same with fewer angle brackets and less colonic problems. Funnily enough, the path is identical. The refactoring path, I find, it does vary from language to language, sometimes modestly, sometimes more dramatically. But it turns out the bit that we're interested in, from the point of view of C++, is basically identical. I do almost exactly the same steps, and I end up with the same solution. So feel free to make changes to the update quality method and add any new code as long as everything still works correctly. However, do not alter the item class or item's property as those belong to the goblin in the corner who will insta-rage and one-shot you as he doesn't believe in shared code ownership. Okay, you can make the update quality method and items property static if you like, we'll cover for you. No, please do not do this. That is a terrible, terrible idea. It is a complete misdirection. And the idea is to make the code better, not worse. Static is a classic kind of code smell. Now, of course, there are cases where we do want to use static, but I actually run a number of workshops, and actually I got the inspiration a couple of times, one from John Jagger and the other from the late Hubert Matthews, of using a no statics challenge. Just tell people no statics, and suddenly their code gets better. It's fantastic. So there's some interesting stuff there. So yeah, we're not even going to entertain that. It's not reasonable. Now, this phrase is doing a lot of work here. Works correctly. How do we know it works? This is one of the variations from the original. In the original, there's just some console output for some examples. These days, people normally tend to provide some tests with it, and the degree to which they provide tests is one of the variations in the way that people often do this Kata. And so I'm going to go with kind of very much the original, but varied as as tests rather than console output, so a simple subset of all the possibilities. Sometimes this is a good example for kind of approval testing, which is how Dmitry Kalandov did it last week. But that sidesteps actually the fact that you have to learn about your domain. That's one of the harder things. And what I always tell people is that the code as it stands is exactly correct. It works. The number of times that people say, yeah, but Kevlin, there's a bug in the code, it's like, no, there isn't. Trust me, many people have gone through this over a decade. It works. There might be a bug in your understanding, but there ain't one in your code. Oh, but the spec's wrong. No, the spec's also right. But here's a contradiction. We'll get to the contradiction in a moment and discover it is not a contradiction, it's a clarification. Feel free to use that play on words, that subtle play on words in future when you are caught out with something. So, no, it's a clarification. I'm not contradicting myself. Anyway, so here is my tidy up of the tests. And what we see is I've got it as an example of existing functionality. Here's our list. We're going to put in a bunch of items. And so we've got a +5 dexterity vest. We're going to sell that in 10. Quality is currently 20. Aged Brie, sell in 2. Quality is at 0. Elixir of the Mongoose, sell in 5. Quality is 7. Sulfuros, Hand of Ragnaros, sell in 0. Quality of 80. Backstage passes, I'm just going to call that tactical because I really can't pronounce that. Concert, and so on. And then we do an update quality, and then we just a bunch of assertions. This passes. So we have some example data, which is kind of interesting. Then there is the not yet implemented example proposed functionality. The bit that we're going to add is this one. Conjured items, and I'll give them one example. But I want to pick up on something because I find a lot of people who do this Kata break certain constraints and assumptions. In fact, I mentioned two examples. Dmitry Kalandov did a subtle breakage of the 2 rules I'm going to give you. Whereas the Sandy Metz one, she completely ignores these compatibility rules, but she comes at it from a very different angle, which turns it into a very different Kata. So there's a compatibility rule. Let's take the words that we've been given. Make any changes to the update quality method and add any new code as long as everything still works correctly. I have a very simple definition of it works. Okay, first of all, it kind of compiles. I mean, that might seem like a small thing to you, but I think that's a starting point. That's why I call it the compatibility rule. It compiles against existing code, and it also passes the test and meets the expectations of the spec, okay? The next thing is the goblin rule, okay? It's similar, but it's related, but it is separate. Now, when we look at this, the real action is happening in the update quality method, the bit that I've highlighted. So, you know, yeah, I think there's a lot going on there. It looks like we're done, but we're not. There is just one more thing. There is a clarification. This is a clarification. Just for clarification, an item can never have its quality increase above 50. However, sulfurous is a legendary item, and as such, its quality is 80 and never alters. Technically, they never contradict themselves because it never rises above 50. Yeah, it is always, yeah, there is a difference, okay? It's a very subtle difference. Okay, so let's have a look at this. Let's try and understand this. There's obviously a lot of ways of understanding this. First thing I'm going to do is I'm going to do something, a signature analysis. This is an idea from Ward Cunningham, which is basically show me give me a summary of each file. Obviously, there's only one file in this case. But what we do is we just basically get the curly brackets, semicolons, and the quotes. And there you go. That's Gilded Rose, all in one, okay? And you might say, well, that's not a lot of use, except it's kind of a histogram. Obviously, if you're doing it with lots of files, that's quite interesting. It gives you a simple bar chart with content of what's going on within a file. It's a very easy thing to implement. It's kind of like a couple of lines of bash, a single line of Python. You know, it's quite an interesting one, particularly when you run it over a series of files. At the moment, there's not a lot we can tell, except, good heavens, we'll come back to that later. Right, so the next thing, the other thing is, okay, C# is a curly bracket language. Let's just drop out the curly brackets for a moment, just so we can see what's significant, because mostly this is formatting. Okay, when we drop that down, we're getting the essential core. Now, a technique I'm pretty sure I picked up from Michael Feathers is to just block everything out to get a real sense of the shape. And this also relates to a technique that I stumbled across many years ago, which is to just try and kind of get a sense of the whole. Choose the smallest font available, just to see the shape. Okay, I discovered this one year, it's about 15 years ago, I think, scrolling through some C++ that was incredibly stable. That's the euphemism for we are afraid to touch it, okay? Nobody had touched it. Nobody who originally wrote it was there at the company anymore. Classic example of legacy. And as I scrolled through it, the screen went blank at one point because the indentation took it outside the viewing window. At that point, I decided to reduce the font size. And it was absolutely fascinating. There was Mount Everest right in the heart of a very simple, small, everything else was quite close to one side, except boom, this sudden monstrous mountain range just rising up in the middle of this class. And ever since then, it's just like, yeah, choose the smallest font. People often wonder, you know, what's the point of choosing a font you can't see? It lets you know what the shape of the thing is. It's just like, that's really interesting. Sandy Metz actually she does a very similar thing, interesting in her talk. She calls it the squint test. If your eyesight is sufficiently poor, then, hey, well done, you've got a tool for free, okay? So yeah, I did a kind of white space inversion, you know, look at the negative space. This is I wrote this as, I called it mountainside. It's just like, okay, let's turn it on its side just to see what we're actually looking at. And it also gives us an indentation level of 6. That's 6 from the baseline of the method, okay? Okay, there's a lot going on here. And then if we superimpose the previous one, it's just, okay, that's kind of pretty. Okay, what else can we tell about this? The other thing is, as we're focusing on all this indentation comes from control flow. So let's pick all the control flow keywords in C#, okay? And then do a count. And mercifully, things like go to and continue. Continue is just one of the, I'm going to just say, if you're using continue, please don't. You know, I've not used it in commercial code for over 30 years. I remember the first time I heard somebody else confess that they hadn't used it for around 30 years was Bill Plowger in a talk at actually ACCU in Oxford in 1998. He said, yeah, every language has a subset. I, for example, have not used continue since the late 70s. I'm now at the point where I can say, I too have not used it for over 30 years. You don't need it. If you think you do, you're wrong. Okay? I'm really tolerant of a whole bunch of other stuff, but continue is an absolute menace. Anyway, we don't have to worry about it. It's fine. So let's focus on this. We've got 3 elses. That's not really enough. There's 16 ifs and 3 elses. Something tells me there's something a bit fishy. And this actually, interestingly, is representative of modern code. There's a whole load of people who've decided to go back to the 1960s. I've noticed this in coding style. There's a lot of people who go around saying, oh, you only need a single branch if, and you should immediately return in all cases. Like, oh, for fuck's sake, do you not, I know that we don't do assembler anymore, but people clearly feel they need it in their lives. So they've gone back to these jump statements. Every if has an else. Whether you use it or not is your choice, but it has it for free. So take it for free and then see where that leads you. It's amazing how much simpler code becomes. But I don't think we've got enough else's, even though this is not true legacy code, because if this were real legacy code, it would have breaks on every single level, continues all over the place, and there'd be some randomly allotted return. But there's not enough of the else's for those ifs. Okay, so we can kind of highlight where the action is, and that kind of paints a pretty picture as well. So there's a lot going on here. Now let me show another thing that I think is interesting. One of the things that I first noticed with this is that this has an interesting state model. Now normally when you think of a function, you don't think, oh, the function has a state model. It does, that's how bad this is, okay? Or it's a classic of imperative coding. How much state is going on inside this function? And it turns out that there's all of this that happens. We adjust the quality. We go through each element of the list and we check the quality and we adjust it based on today. So we're at the end of the day, and what we're going to do is we're going to adjust the quality. See, we keep adjusting it based on how long we've got to sell it and based on what it is. And then we change the sell-in thing. We pass the stroke of midnight, and then we do it again. We do some more adjustment now that it's tomorrow morning. Or put another way, this code takes place across 2 different time zones. That feels somehow wrong to me. Even in an imperative language where state and state change are part of the deal, it feels needless and excessive. Okay, so this feels uncomfortable. It's difficult to reason about. Okay, so one of the things that observed a really nice piece in 97 Things Every Programmer Should Know. Seb has the first article in the book. Act with prudence, if I recall correctly. The book was alphabetically ordered by title. I don't think you knew that, but he got in there, act with prudence. Nobody submitted aardvarks for development. That would have beat it. But thinking in states, lovely piece by Nicholas Nilsson. In most real-world situations, people's relaxed attitude to state is not an issue. Unfortunately, however, many programs are quite vague about state too, and that is a problem. People don't really have a good grasp. And this is particularly worrying in languages that are massively imperative and rely on side effects. So let's actually look at what is the state being referred to. If you go through, then item I.quality seems to be kind of a biggie. We seem to actually refer to that a lot. We also assign to it quite a lot. There's a sort of, it seems like we're a bit indecisive. Let's assign to it. Let's assign to it again. You know what? I don't think twice was enough. Let's assign to it some more. It's like we can't make up our mind. And that, for me, without ever being able to define it, and as a one-time Fortran programmer, I can definitely say if you constantly keep going back to a variable to change it, that's the code telling you something. Why couldn't you just get it right the first time? What is it that has caused you to mess this up so badly that you can't actually arrive at, what's this variable going to be? Some people have taken the vary part of variable to heart. They constantly check, oh, I need to vary it some more. I think it's remaining a little bit constant for my liking. I don't think this has changed in the last 5 lines. Let's modify it. you need to look. That's the bit that confuses us. You know, you're busy there, kind of, okay, and that and this value, and I'm looking here, and that value is that. Oh no, sorry, forgot that it was actually modified over here and here and here. So what is interesting, actually, if we generalize, zoom out, broaden our scope a little, where are all the assignments? Assignments constitute nearly a third of the statements. That's interesting. So this is interesting because I don't know that many people look at the code in terms of what changes. They start looking at it from other perspectives. I think some people do this. I noticed that, I've seen this in a couple of refactorings, but just as a general way of looking at code, is the bits that don't change, you probably don't have to worry about as much. It's the bits where the change happens, because change has this habit of sometimes being wrong. But if you don't change it, then it's as right as it was before. Okay, remember I said we don't seem to be able to let items I quality go. I found one path that modifies it 4 times. It's like, for heaven's sakes, make up your mind. It's in the handling of backstage passes. We'll come back to that one. Okay, so, you know, this is just a minor rant. Back in the days before we called paradigms. This is John von Neumann, who was one of the people, no, not John von Neumann, John Backus, sorry. He talks about the von Neumann style. John Backus, who was one of the people responsible for inventing Fortran, but then he atoned for this by really advocating functional programming. So this is his 1977 Turing Award speech published in 78. It's interesting because he refers to it as style. The word paradigm is not present in the computer science literature until 1978, late 1978, 79. We'll come back to that one. But he makes a point. He says conventional programming languages are basically high-level complex versions of the von Neumann computer. Von Neumann programming languages use variables to imitate the computer's storage cells, control statements to elaborate its jump and test instructions, and assignment statements imitate its fetching, storing, and arithmetic. Yes, this is all of the languages pretty much that we're talking about this week. And this inspires us to refactor. So what is refactoring? Let's try and take the perspective of the manager. So this is commit strip. Wonderful cartoon, also available in French. So will refactoring the code improve the loading time? That's the manager. Developer, not really. Well, will it improve security then? No. So it's for browser compatibility? Absolutely not. So tell me, why is it always the same old story with you guys wanting to refactor everything? I need to know. Because as devs, if we know we've left messy code, we can't stop thinking about it. When we wake up in the morning, at lunchtime, in the evening, when we go home, and when we're trying to go to sleep, it haunts us. So that's often the way that people think about and reason about refactoring. They come at it as an antidote to technical debt. I've already mentioned the issue with technical debt. The point is that I'm not saying refactoring is not about this, and certainly this exercise is, but we need to construct a more positive view of refactoring. Refactoring was never introduced just to deal with crappy code. That's not its motivation. It's much deeper. So my friend Rowley, when talking about refactoring-driven software engineering in Python, he said, what is refactoring-oriented software development? A variant of test-driven development that places a special emphasis on refactoring. The idea here is a kind of a subtle distinction here, in the sense that it is heavily reliant on tests. He says it's a methodology for software development that relies heavily on refactoring and tests, and the tests are to check for behavioral invariance rather than correctness, a subtle distinction. So if it's broken and passing, if the tests are broken, or rather if the tests are wrong and everything's passing, you're going to preserve that. But the focus here is very much the idea of moving all the pieces into place, not necessarily driving through a broken test, not necessarily driving by saying, here is where I want to be, here is a test for the behavior that I'm going to add, and that's how we're going to drive and pull our refactorings along. It is a slightly more anticipation-based approach. In other words, I want to be over there, and what I want is I want to minimize the amount of time adding the new feature. In other words, I want the addition of the new feature to be one small step, trivial. And when Rolly and I were talking through it, he gave an example. He said typically when he's committing stuff, he says it's about one commit in 30 is actually something that changed the behavior, something that actually was the requirement. Everything else was just moving into all the pieces into position. And then the final bit, trivial. Absolutely, the adding was no effort. So you can see there's a strong relationship there. And I found it's also very close to the way that I think about a lot of development as well. but we don't place enough emphasis on that as a style of a way of thinking. In fact, if we look back at the original refactoring book from Martin Fowler, we can even see improving the design of existing code. He talks about it as it's not just a tidy up action, it's about the design. Now, in this case, he gives us a very precise term, one we're going to come back to a few times, a change made to the internal structure of software to make it easier to understand and cheaper to modify without changing its observable behavior. What we mean by observable behavior, we'll come back to, but mostly we're talking about it in terms of tests. What I find interesting is without changing, actually that uses exactly the same definition in the second edition of the book, which was published a couple of years ago. Lots in the book changed. Original used old Java, pre-generics Java and JUnit 3.8. This one uses JavaScript. So basically kind of like, as well as living in a world where automated refactoring is much more normal, the previous one did, but nonetheless, all the guidance is the same. Ironically enough, this stuff didn't originate there. It was popular. I didn't come across the term until extreme programming became popular in the kind of mid to late 90s. But actually, the original work on automated refactoring was done by Bill Opdyke. The late 80s and early 90s. Ralph Johnson, better known perhaps for being one of the co-authors of the Design Patterns book, The Gang of Four. A lot of good research done in this, but what always gets me is the fact that Bill Opdyke was doing all his work in C++, the language that received none of the goods from refactoring, and everybody else got all the goodies. It's just like, you talk to C++ developers, and they're just like, yeah, refactoring, I see other people doing that. Refactoring tools, it's something that happens elsewhere. But again, his emphasis, they're defined to be behavior preserving. So we need to rely on tests. One of the things that Rowley said is very much this relies on tests. He's not relying on automated refactorings. The demo that he does on this one, he does it in Python, no automated refactorings, and he's just using kind of integration acceptance style tests. You just need to baseline your tests at some level. It's up to you to choose the level that you're at, that you find comfortable, that gives you enough iteration and does not cause too much friction in terms of breaking tests. So I'm not going to do that. I'm going to write tests for people. In other words, I'm not just going to assume, I'm not just going to take snapshots and do approval testing style stuff. Write tests for people. Jerome Mazaros had this nice, he wrote this stonking great book. It's the book of test patterns. It's 900 plus pages. It's one of those that you can use as a weapon, should you need to, against your colleagues. This is how you test. But I got them down to 2 pages for 97 things. And it's very, very clear. Who should you be writing tests for? Not the build system, okay? For the person trying to understand your code. Not your test code. You're not writing your test for people who want to understand the test code. They're obviously part of that. But it's really more for them as an audience, people understanding your production code. This plays the role of active documentation. Now, so what I've done is so using NUnit, give tests a bit of structure. Give them a bit of 3-dimensional structure. Okay, well, 2-dimensional structure strictly speaking, but the other dimension, the bodies are hidden. So a much more literate style of testing. Gilded Rose spec, quality of a normal item decreases by 1 every day before its sell-by date. Quality of a normal item decreases by 2 every day past its sell-by date. Never decreases below 0. Quality of aged brie increases, etc., etc., etc. So something you can actually read off. It's a structured spec. It tries to make sense of the original spec, and it works against the code. This kind of approach to testing and structuring your testing, you can do it in most testing frameworks. The idea of nesting things is something that I find is missing from a lot of test code. You can't do it in certain frameworks. Some frameworks you're kind of limited to only two levels. For example, if you're using Google Test, you've got 2 parts to the name, and the practices and constraints they describe around those I generally ignore those because what does Google know about testing? It turns out they know a lot about testing at scale, but some of the guidance on the detail could be improved. In C++, I recommend Catch from Phil Nash. I'm biased on that one because the original design of the nesting came from me, so I think it's a great idea. But the whole idea is that most things, most languages, most frameworks will allow you to do something like this, take advantage of it. So we're looking at what we mean by good tests. So 97 things every Java programmer should know, which I finished with Trisha G. I think the first wave of lockdown, actually, in 2020. And I think if Gail's still in the room, Gail's still in the room. There's a picture of Gail somewhere on there as well, contributed an item. And there's about half of this stuff is just applicable to any language, particularly the piece by Marie van Dijk on testing. Let's talk about the quality of tests. What do we mean? What do we want our tests to do? And one of the points that she makes, which I don't hear enough people making, is your test should tell you what, when it fails, it should tell you what's wrong. And it should do slightly better than, hey, there's something wrong, which is what most tests tell you. Here is a thing that did not work. Why? We have no idea. What am I supposed to tell me? Test 14? What do you mean? I have no idea. Okay? You know, in other words, we've got something and we've got information and it's not enough to work with. We suddenly have to become detectives. So a failing test should tell you exactly what is wrong quickly without you having to spend a lot of time analysing the failure. This means each test should test one thing. Okay, we can discuss what we mean by one thing, but the idea of some kind of coherence to your test is important. Use meaningful descriptive names. This may be the least useful piece of advice anybody has ever given anybody on names, which is why it's important that Marie does not stop there. Because I've seen people say, oh, you should use meaningful variables, but I is meaningful. Yes, but you've used it in different ways, in different functions, at different levels, and even shadowed earlier definitions. Yeah, but it's so short and so perfect. No, I is imaginary. We want something real, okay? Bit of complex humour there. So the point here is, in fact, not too far from here, there was a developer, and I never met him. This is back when I was doing time in the Fortran mines. My boss told me that when we were having one of those developer discussions about meaningful variable names or variable names and whether one should use goto or be sent to hell and that kind of thing, he said, there's a problem with the word meaning because normally variables always mean something. And he gave the example of one of the developers on site that was just towards the station, one of our clients. He said, there's a developer there who he uses meaningful variable names. The first variable that he identifies in a function he calls A. The second variable he identifies he calls B. Yeah, he's even got as far as M, And the point there is if you say, but this variable T, it doesn't mean anything. Yes, it does. It means the 20th variable I thought of. It has a very precise meaning. So, descriptive is important, but what? To what end? Don't just describe what the test does. We can read the code. Tell us why. Give us intention. This can help us decide whether a test should be updated in line with changed functionality or whether it's an actual failure that should be fixed and found. Okay, you've gone and made a change and then a test has broken. One of two things has happened. You have introduced a genuine bug or, oops, you forgot to update that bit over there. You were so focused on updating the really tricky thing, the easy things just escaped your attention. Okay, you need to understand clearly from that. And never trust a test you haven't seen fail. Yeah, I'm sure we've all ended up passing, this is working great. I'm having such a productive day. Oh, that's actually not running as a test. Okay, or I'm testing something else. I copy and pasted, or exactly, one of those. We'll come back to this one later, but generally mutation testing and just, code review and pair programming, these kinds of things kind of help you with this. So let's go back to this. So all my tests are parameterized. I've taken the examples and then run with those. I've also extended them, okay? A little bit of creative, it's fun creating new test data. I mean, what else fits with this kind of language and these examples? I don't know anything about World of Warcraft, but I'm gonna have good fun. Sour bread with wry humor and cold vengeance seems good to me. You can tell that this was early on in the pandemic that I started using this data because everybody was doing sour bread. So the body, relatively simple, fairly tedious. There's probably some more we could do on factoring out setup, but I'm not going to concentrate on that here. Set stuff up, update quality, explore our expectations, okay? And that kind of follows a narrative that many people are familiar with as the 3 A's, arrange, act, assert. We do BDD, given, when, then. These are isomorphic. Given a choice, always choose the one on the right, because first of all, it sounds like English. And secondly, it works at any level you intend to talk about the system, whether you're talking about the detail of units, system level test, or conversational with a client. The given when then structuring always works. But the point is, these are isomorphic. They're not different. Sometimes I get, oh, now we're doing BDD because we're using given when then. It's just like, that's not the hallmark of BDD. Trust me, it's not special to that. These words are about 1,000 years old in English. Maybe BDD is that old, who knows? Seb, no, yeah, I didn't think so. Dan Terhorst North came up with it just before 2003. So yeah, it has an origin story and we know it. Okay, so then I take the original test and I actually keep the original test and just to use it to highlight the quality of it changes independently of other items, because most of the tests are about individual changes and I just want to highlight that. Now let's explore a little bit some kind of taxonomy here and think about the stuff that we've got. We've got items. We've got normal items, Elixir of the Mongoose. We've got backstage passes, okay, so to the Tafka concert. We've got aged brie and we've got sulfurous. So that seems kind of reasonable. Now, there is a question here as to whether we should think about sulfurous as specifically being a legendary item, because the terminology in the spec did call it legendary item. The problem is it doesn't do so in a way that makes it sound significant. It just says, oh, it's just a legendary item. It's just a passing comment. And we are never given the sense that there might be more. And at this stage, I'm going to say, you know what, I'm keeping it simple. I'm not going to overgeneralize. I'm just going to say there is sulfurous. If we do end up with another category, then we will change the code, because guess what? We care about refactoring. That's the whole point of this stuff. So we're going to do that. Now, a lot of developers, instinctively, when they are let loose on this problem, I'm not going to say all developers, but I'm going to say a lot, they don't necessarily think in these terms, but you can certainly feel them building a class hierarchy. And that's the class hierarchy that actually comes out of that diagram. Okay, that set diagram directly translates to this. But oh no, it turns out that a lot of people do this instead. We're going to inherit from a concrete base class. This is not a good thing. It normally leads to some interesting philosophical questions and some contradictions. This is a normal item. This is not a normal item. Therefore, sulfurous is a normal item. That's what this says to me. It's like, yeah, that doesn't really make any sense. Oh, okay, well, we'll just change it to item. But now I've got a missing classification. The majority of items don't have a way of being referred to. Granted, we never use the term normal in the text. It's a term that we have to read between the lines, but it's actually the dominant type. So this class serves two roles. It serves to represent the classifier of actual instances and the root of a base class. That's two jobs. Honestly, keep it to one. So keeping it abstract, we've got this. However, if you were to do this, you would run foul of the Goblin rule, because you have to modify item, which is, if you remember, basically just a glorified struct. It has absolutely no virtualness to it whatsoever. There is nothing to overwrite. So yeah, this is not going to work. So then people typically say, I have a cunning plan. Let me add a shim class, an adapter that is abstract. And so we've gone concrete, abstract, concrete. The abstractness will be crushed under the weight of the concrete. I once created a class hierarchy like this. Never again. I thought it was really clever, really subtle. And then I woke up and it was all a terrible dream. Sadly, I'd already committed to the code base. Yeah, don't do this. So yeah, Anderson's law. I've yet to see any problem, however complicated, which when you looked at in the right way, did not become still more complicated. So here's actually what happens. The stuff on the left is this version you started with. If I actually refactored this to use a class hierarchy, it would look like in the same style as the code is in terms of indentation and curly brackets. It will look like the stuff on the right. You haven't really saved much. Granted, it takes a little less space. The logic is certainly tidier, but lengthwise, we haven't really improved matters a great deal. So this also doesn't compile. I would regard that as a greater objection. You might say, yeah, but Kevlin, it's a perfectly fine abstraction. Yeah, but it doesn't compile. Yeah, but apart from that, because it runs foul of the compatibility rule. Any code currently written in terms of the previous one will not work. Okay, so here we are. We have a problem. We're feeling stuck. Use the rule of 5. Little things to start being more productive, focused, and happier. Yeah, one of those kind of like, things that pops up in your feed. Helpful productivity. So the only reason I'm quoting this is, well, 2 reasons. One is it happens to fit the narrative in a kind of post hoc way. I read this article relatively recently. Do we have a date on it? No? No. Relatively recently, this year, and I thought, oh, that'd be good for the refactoring talk. It kind of fits, but also because actually it quotes Joe Satriani. It's just like, yeah, it's great. So advice from a great guitarist. I picked up a great tip from producer Jim Scott. I wasn't happy with the song. Couldn't articulate why, just knew I needed to record the whole thing over again. It's no good, we need to do a rewrite. He said, pick 5 little things that really bother you. We'll fix them, and then you can listen to it again. I picked 5 that he didn't think detracted from the song, so he fixed them. Some were just half a second long, but they bothered me, and it turned out great. That was a really good lesson. Actually, in one sense, I'm going to say we've already started. I'm going to give ourselves a free extra, 0. Tests are neither expressive nor extensive enough. That was something that bothered me and should bother people. Sometimes people will launch into trying to add the conjured items without doing any refactoring or having any tests. Good luck if you expect that to work first time. It doesn't, okay? So you're going to need some tests. Also, the tests allow you to understand. Your problem here is not typing. Typing is not the bottleneck. It is understanding. You've just been presented with a new domain and a whole bunch of code that's not yours, okay? This is basically like working with ChatGPT, okay? So the future of programming is we've all turned ourselves into maintenance programmers. We took the fun bit and we're just going to give ourselves code that somebody else wrote. Great. I believe that's called an own goal. I've taken this and turned it into that. So yeah, I think that's good. Let's move on to the first thing. The one that always bugs me, and I'm surprised at the number of people that never modify this, because it changes the way that you write the code in the loop, is what the hell's that for loop doing? I mean, this is a language that landed with a for each construct, yeah? And I see exactly the same problem in C++. People will just quite happily leave that for loop, even though we are in a post C++ 11 world. It's just like, yeah, you've got a range for, you can use that, that's fine. And bizarrely enough, I've even seen it in Python, which is a language in which it's actually quite difficult to construct a counting loop. And yet people have really stuck with it. So yeah, all of this, kind of counting through this, I mean, it's nice to see the mechanics, but, honestly, life is easier. So yeah, that's nice and easy. Okay. The next thing that bugs me, okay, there's just small things. Non-idiomatic arithmetic. What do I mean by that? You can't see this, so let me highlight and zoom in. If you look at all of these, item.quality equals item.quality minus 1, okay? Item.quality equals item.quality plus 1. It feels to me like it's a classic case of the programmer was either some crazy computer science purist who still thinks that Pascal is a good language, or it's somebody who's just not familiar with the language, okay? In other words, we have a way of saying this, okay? We just decrement it, okay, or increment it. This is kind of built into the language, take the gifts that are offered to you, okay? It's only been an idea since 1968, okay? It's not some newfangled idea. It was introduced literally by Algol 68, introduced these kind of compound operators. C took it the next step by just saying, 1 is a special case. It's often enough that we'll use that. Okay, so that actually allows us to change all that code. Okay. Now, it's a bit of a biggie, this one, clumsy conditional logic and structure. Yeah, that's kind of most of what's going on. So what I'm going to do is I'm going to zone this first of all. I'm going to deal with today's time zone, okay? Let's deal with today before we are about tomorrow. And if you look at this, there's a lot going on. It's just like, okay, and there's a lot of negatively phrased stuff. And I'm not on some kind of like positivity kind of trip here. It's just a little bit hard for human beings to understand things that are always not. It's a little bit messy here. So there's a lot of this stuff going on. So the first thing I want to do is I'm going to get rid of some curly brackets. Some places have a religion where they're supposed to put curly brackets around everything. Honestly, you don't need to do that. Let me just tell you. But no, you don't. It's okay. We have static analysis. We have compilers with intelligence. It's okay. The dangling else problem is something that people used to suffer from. But if you're saying, but we compile without warnings, then that is not my problem. You've just told me what your problem is, okay? So the idea is don't waste the space. For me, actually, I find it quite useful because I want everything, in a language where I am forced to make a distinction between compound and single statements. I use that distinction constructively. I'd rather the language wasn't like that, but I use that distinction constructively because I want to know where the code is complex. In other words, there are two things going on. I want to see that. If there's just something simple, then that's great. Let's just mark it as something simple. Don't give it more real estate than it deserves, okay? So I'm just going to reduce that down. That immediately lets me see a very different kind of structure here. Now, the first thing I'm going to do is I'm going to apply De Morgan's laws, okay? It's kind of like that stuff at the top. Item name not equal to HBRE and item name not equal to backstage. Okay, let's just turn that into this, and that's a not with an else, so we can flip it upside down. Great, that's a nice inversion. If item name equals HBRE or item name equals backstage passes, and then we see we're doing something else with backstage passes, it's just like, well, tell you what, let's split this out into two parts of if, okay? And so before that, one inversion. We seem to be checking quality consistently on the inside, but here we check it on the outside. So I'm going to flip that round. If you've got two ifs, one immediately following another, it's equivalent. You can flip these around. It's equivalent to an and. I'm not going to refactor to an and. But you can do that, and then you can fold that in, and we've reduced another level. But the next one I want to focus on is this. I'm going to duplicate that first part. Okay, I'm going to turn that or, which seemed to be, I'm not saying you never want to use an or, it's just that it seemed to be the fact that you then made another check on exactly what you just already checked. That smells, okay? The point here is if you are checking a condition you've already checked and you know that it's true, then you know that it's true. So let's refactor that. So duplicate those signs. And an important point here is that some people are afraid of duplication. They think of dry as a principle, don't repeat yourself. First of all, dry is not just about code duplication. It's about duplication of information or knowledge. If you ever wonder whether you should be using var or auto, the answer on not all cases, but in most cases is probably, because most of the time you're duplicating something that's already on the left-hand side that's already on the right-hand side, yeah? But some people see this as a key principle. It's even called the dry principle. I don't think of it as a principle. Think of it as you probably want to do this. It's a 90% rule. Yeah? If you're in doubt, don't repeat yourself. But there are cases where a little bit of duplication will allow you to just loosen things up a little bit. So go from dry to wet, right every time. And then once we've done that, it turns out that this is surprisingly simple because we just eliminate in each branch all the stuff that we had to kind of double check as being true. Well, we already know certain things are true and certain things are false. So therefore we can just get rid of that code. It's dead code. So, that's kind of nice. Okay, so that gets us some of the distance. Now, important point here is the way that we have approached this. It's small steps. And what I think is interesting here is that that's sometimes the thing that we find difficult to do. We have a lack of patience. We want to get to nirvana. We want to get to the good stuff. So we're impatient. We also sometimes remember that day when we managed to hold everything in our head and it all worked out beautifully. And we think we can recreate that moment or that day. Most of the time we're wrong. It's just like, yeah, and now none of it compiles. One client a number of years ago, we were having a conversation and refactoring came up. I said, yeah, we've been refactoring our code base. Oh, cool. So how's that going? Tests. Oh, we're not using tests. Okay. But you can lean on the compiler. Yeah, we haven't compiled it in 3 weeks. There is one, I talked about dry, I talked about wet. I'm going to give you another 3-letter word. Run. Okay, run. That was frightening. Yeah, it was somewhere in the home counties, I don't care which. I was in a car later and that was it. I was leaving then. If you make a mistake, it's easy to find the bug. Yeah, just work in small steps. It's the idea, quite literally steps. Think about refactoring as being a case of working in steps rather than running, okay? Difference between, what is the technical difference between running and walking? This is the bit where you say something. Yeah, points of contact with the ground. Okay, if you ever watch, the only time anybody ever watches, sport walking is at the Olympics because they've got the TV on and they go, wow, that's a bit weird. You will notice that there is somebody always by the track looking at the walker's feet because running is defined as going through 0 points of contact with the ground. Yeah, 0, 1, 0, 1. That's why programmers like it, okay? Walking is 2, 1, 2, 1. 2 points of contact, 1 point of contact, 2 points of contact, 1 point of contact. You're always going through some redundancy. You can stop mid-step, okay, and still be in stable configuration. Whereas if you've ever fallen over while you are running, you will know that it's slightly more severe than falling over when you are walking. Same with code, okay? So we're going to walk, okay? Let's deal with tomorrow. Okay, let's tidy this up a bit. So, yeah, lots of indentation. Beautiful as art, but perhaps not so helpful as code. I'm going to skip all the steps and just cut to the chase. It's just like, yeah, that flattens quite a lot and simplifies things. So, yeah, here's what we've ended up with. And that's kind of a significant improvement. Just to remind you, that's what we had, and this is what we've ended up with. So there's a bit of compactness, but we've also reduced the indentation level. And there's less going on, but let's actually focus on some of the things that are going on. That quality value, most of those things are, if it's greater than 50, if it's less than 50, is it greater than 0? We're checking, constantly checking. Should we do a state change? Have we met the condition? We're basically checking, remember, the quality can never go above 50, it can never go below 0. So therefore, when we're incrementing and decrementing, there's this kind of hesitant thing, is should I or should I not? And we're doing that in a lot of places. Why? Because we have so many places we're making changes. So of course, we're having to check absolutely everywhere. So if we look, these are all the places we're doing these checks. Okay, and every single one guards an increment or a decrement. What we can do here is recognize that there's actually a name for this kind of limiting, this thresholding. That actually a well-stocked library will give you min and max, okay? And there are some languages that don't have those. That's fine. You can write them. If you think that that's a hard job, trust me, it's not as hard as this, okay? So the point there is that this is the simple thing. In other words, communicate with intention. And you let somebody else do the work, the library in this case. Okay, now, quality is repeatedly readjusted for backstage passes. Yeah, we noticed that one originally. That one bugs me. We don't seem to be able to let it go. We keep poking and prodding it. So let's just focus on that. So even in the simplified form, we're still doing that. We modify it, and then potentially modify it again, then potentially modify it again, and then after the date line, we might modify it once more. This doesn't feel right. So, first of all, what I'm going to do is I'm going to extract a variable that tries to capture the intention. What is it that we're actually trying to do here? We're trying to adjust the quality. So I'm going to introduce a simple variable called quality adjustment. We're going to work on the quality adjustment, and then we're going to apply the quality. So in other words, first we're going to separate these things out. I have some state, I would like to change it. Instead of constantly poking that state, I'm going to work out what the change should be. I'm going to calculate the quality adjustment, and then I will apply it. Okay, that works quite nicely here. The other thing is I feel a little uncomfortable with what's going on here. Again, this accumulated approach. Never underestimate the value of an else. Okay, so that's what's really going on. If you think of it as perhaps it's so deeply ingrained in your thinking that you're thinking, yeah, we constantly modify. No, there are actually 3 different paths. There's what happens when it's older than 10 days. These are different paths. They are separate actions. They're not combined actions, and it's not clever to do that. Okay, it's just a side effect. Now, strictly speaking, what would be nice is if I could write this. In other words, the whole point is if you find that you're constantly assigning the subject of this, let's use a bit of linguistics here, the subject of this if statement is quality adjustment, and yet it has a secondary role. There's a lot of assignments and a lot of code that's like this. The goal of this is not to if, it's to assign quality adjustment, but it's given a secondary role. What I actually want to do is do it like this. Okay? quality adjustment equals 1 if the item selling is greater than 10, 2 if the item selling, otherwise it's 3. There's only one small problem with this. Any C# experts in the room? And what's the problem with this? Doesn't compile. I consider that to be an obstacle to progress. Okay, we could use the conditional operator, but generally people don't thank you for that. Yeah, I think the conditional, I have no problem with the conditional expression for, if it's just 2 things, that's great. And if you're not using that, then, we need to have a conversation. That's fine. Syntactically, it's visible, it's clear. It's just that this doesn't naturally lend itself to that. We could try and kind of do this kind of immediately invoked kind of function expression thing, which kind of gets us a little bit closer. And if you do JavaScript, you do C++, you may be familiar with this. There's only one small problem with this in C#, which is it doesn't compile. Again, an obstacle to progress, because lambdas are not first class in C#. Okay, lambdas are not truly objects. They're kind of objects behind the scene, but you can't talk about that. We don't talk about that. Yeah, you cannot utter their name or anything like that, and you cannot use them immediately as if they were actually useful. So a little bit of work to go there. So maybe I can do this. And what I'm going to do is I'll create it as a function object, and then I will apply the quality adjustment here and do that. At this point, one of your colleagues needs to come along and maybe just whack you around the head a bit, It's a very, very common problem, okay? I have no problem with the kind of functional thinking going on there, but what I'm going to do is I'm going to accept in the language that I'm in, I can't do this. In Kotlin, I can do it, okay? In Rust, I can do it. In C#, I can't. In C++, I can't. It's as simple as that, and that's fine. I'll just work with the tools that I'm given at this level, so I'm just going to leave it like that, and I'm happy to do so. So it's kind of worth seeing kind of where we are with this, because there's another thing I think is interesting. Actually, I've got the built on that completely wrong. There we go. So what we've ended up with is something that actually corresponds to the original description. In other words, the original description did not say add 1 each time we go past a range boundary. I find it kind of funny whenever developers end up talking, writing requirements, the number of times I've ended up with developers writing user stories, and they go, oh, well, you do this, and then it increments this. I said, people do not increment. That's not a thing that humans do, okay? I am holding up, I'm holding up 2 fingers. Now I'm going to increment. No, I'm just going to hold up another finger, okay? Just talk in the language of the domain. And in this particular case, it turns out that with these numbers were already present in the original problem. It's like, oh, okay, fine. So we've just done 5 things. Instead of starting over, fix a few things that bug you, often you'll find those little fixes totally change your perception of the whole. Actually, my perception of the whole has changed. Because what we've discovered is this. I'm going to keep on using the numbering, even though we've used the 5 things. But these are not necessarily things that I'm now more proactive, because I've actually had a breakthrough. These are things I'm going to do. I'm going to generalize the use of quality adjustment, because it turns out that this is the abstraction that we needed. It's not an object abstraction. It's not a functional abstraction. It's not a procedural abstraction. It's just a simple data observation that what we're trying to achieve here is quality adjustment. And although I introduced it for backstage passes, we can generalize it. So I'm going to pull it out. And I'm still, at this point, I'm not using it anywhere except the backstage passes, and I'm still applying only there. Just a reminder for anybody who is viewing this through the lens of C++ and is sitting there going, oh my goodness, I can't believe he left that int uninitialized. It's okay, I'm working in a proper grown-up language. It tells you when stuff doesn't get initialized if you try to use it. It's not a warning, it's an error, okay? It's one of those things that, a lot of people, it's always funny having this debate when in a C++ or C context. Oh, but that might break existing code. Code that deserves to be broken. Okay, let's be very clear. Okay. If you want undefined behavior, you ask for it. You don't get it for free. Okay? Yeah, the idea is there is no meaningful code that is going to be broken in a severe way. with this. We should help people. There's been a whole recent discussion about, can C++ be made safe? Until this problem is fixed, you're not even on the starting blocks. You're just talking about the way you could be safe. No, you've got to do something. And really simple stuff that has been proven for decades in other languages. Flow analysis. We use it in optimization. Why don't we use it for correctness? Okay? So, rant over for the moment. Okay. So what I'm doing here is I'm just going to fill out a few things. I'm going to add in a specific case. I'm going to invert that condition where I was ignoring. If it's not sulfurous, then I'm going to do my normal item decrement. Actually, I'm going to make a special positive case for sulfurous. We do nothing in that case. Otherwise, it's a normal item, and then we decrement. And then at that point, I can now move everything to use quality adjustment, and then apply it. So in other words, what I've got here is I set up, and if you miss out any of these, it will not compile. So what we've got here is a really interesting case that I am going to calculate the quality adjustment. If you look, quality adjustment is only ever assigned to once on any path. This is an assign once discipline. If this were Java, I would be able to do this with what's called a blank final, which is you can think of as a deferred const. In other words, basically, this will only ever be assigned to or initialized once. If you try and do it a second time, you'll get an error. If you try and do it 0 times, you will get an error. In other words, the compiler does what compilers are supposed to do. Yeah. However, that feature is not available to me in C#, but that's what I would do. I would want to declare that final just to make that point. So in other words, we work out what the quality adjustment should be, and then we apply it. And that means we end up basically here, if there is a quality adjustment, then we apply it and we move cell in. Okay. Max min, clamp, does the job. So we're done. Well, not really. It's that bit at the bottom. Further quality adjustment does not depend, does not. I think I might need to modify that. Should not depend on changing cell in. That bit, the tomorrow, the date line. This stuff down here. Again, this is all about item quality. This would be beautiful as an if expression. Sadly, those don't exist in the way that we want them. So what I'm going to do is I'm going to peel off each case. I'm going to start off with the simple stuff, the normal stuff. The normal stuff I'm going to migrate up to there. And there I'm going to use the ternary operator because this is really quite simple. It's quality adjustment. If the cell in is greater than 0, then it's nice and simple. And then I'm going to move the others bit by bit, and backstage passes finally gives me the full story. So in other words, we've just eliminated the date line. Everything is done. We only ever figure out our quality adjustment once, and then we apply it. So looking back at this, let's revisit some of the things. This is where we started. This is what we've got. Oh, that is an improvement. We've got this. If I look at this from the point of view of just the structure, yeah, most of the code is there. I don't have to knock away formatting too much, and that's kind of visible. If I block it, that's actually kind of okay. Nothing to, the mountains, the mountains have gone down. Okay, the mountains have fallen. It was an indent level of 6 before, it's now gone down to 3. Superimpose, yeah, that's kind of nice. Then if we look at the control flow, the balance has shifted, but not, it's shifted a bit. Oops, let's go back. Oh, yes, sorry, I've got the builds wrong on that one. What we've got is, we've now got 6 else's, 1 for each, 7 ifs. However, I do want to be completely honest about this. I have used the ternary operator, which didn't exist before, so let me just generalize that appropriately. What is interesting here is that we have almost as many else's as ifs, which is kind of nice. I'm not saying you should always have, please don't take that as a kind of a guideline. There is a thing sometimes people refer to as space shuttle code. It's older than that, the idea that every else should be explicit. I have worked in a language where every else should be explicit. It was an absolute pain in the backside. But it is a useful discipline because it makes you think more of the time. I should be doing structured program. I should communicate my intent and not rely on short-circuiting or cumulative state change. If I mean to say it, I should say it. This is an alternative. We actually have a keyword for that. It's called else. So if you want to present alternatives at first-class level, That's the way to do it. Also, it's a lot easier to refactor when you have code like that. You can flip it upside down and move things around very, very easily. The date line thing, yeah, we kind of solved that one. In fact, more to the point, this is the only place where there's state change. Okay? We've now got only one part of our function includes movement or mechanical movement in that sense, which is quite nice. So we did that. What I like here with this observation about refactor as a verb is that and this is something a lot of people missed in the book. When Martin introduces this, he uses the plural to refactor the verb, to restructure software by applying a series of refactorings without changing the observable behavior of the software. A series of refactorings, plural. This is one of the most interesting things, is that refactoring is, rather than thinking about it, I'm just going to do a rename or whatever, think of it as a series of steps, a journey. What are the way stations on my journey? Okay, rather than just as single actions. Okay, it's actually a composite whole. Okay, now what we're going to do is a couple of tweaks before we do the final addition of the functionality. Generalized matching of sulfurous and backstage passes. What do I mean by this? Well, this was kind of the model we had before. But actually, if you look at the code, what you have is that it's hard-coded to only one kind of concept. To one concept, where it's like, well, that's nowhere in the requirements. The requirements suggest backstage passes. But actually, there's only one concept available. That maybe bands, maybe there aren't a lot of bands in the world of Warcraft. I don't know. But I suspect we might want more. And also, even though we keep referring to sulfurous, in the code, it's hard-coded to sulfurous Hand of Ragnaros, even though we call it sulfurous. So I'm actually going to make the code do what the requirements suggest. Crazy idea. Okay, that will never catch on. Let's go back to Mareed's observation, never trust a test you haven't seen fail. So I'm going to take the test that I've got for quality of backstage passes. Everything is in this Tafkol concert. And I'm going to add a bunch of tests that don't work. Okay, I'll make up some stuff. Okay, so these don't work at the moment. So we're going to go to the code. You see, yeah, it's all hard-coded there. And I'm just going to go starts with. This is a very text-driven application. Everything is done by classifying text. I see, and so therefore I'm going to assume, I can extrapolate from this, say, right, anything that's a backstage pass, begins with backstage passes. Okay, so let's do that. And I will seek confirmation, do demos and whatever, to get the feedback of have I understood this correctly. But from the coding point of view, yeah, this works fine. That's great. The next one is sulfurous. Okay, let's actually call it sulfurous in one place. That fails. Again, same kind of generalization, starts with, okay? And that passes. So that's kind of a small tidy up. And then let's add conjured items. So let's understand what we've done so far. Some of you may have seen me talk about this, because I find it quite a helpful way of understanding the changes that we're doing. Kind of right-hand rule, okay? The changes that we're doing to code fit along essentially three axes. Okay, they're not perfectly orthogonal. There is overlap, but guess what? My fingers aren't perfectly orthogonal. This is a very good model. Okay, it's very faithful. But it's a useful way of reasoning about it. It also gives you a vocabulary for understanding how you might want to separate out your commits. The idea here is functional behavior, semantics. When we are talking about saying this is behavior preserving, that's what people normally mean. It's the functionality, it's the semantics, it's the unit tests, it's the integration tests. These things continue to remain stable. Operational capabilities, in other words, how it runs, the performance characteristics, basically. How much memory does it use? It's not a question of correctness with respect to the semantics, but does it run fast enough? Does it run within our constraints of resources? These are the questions we ask here. These are a little more challenging to talk about and to test, but tend to think of them on these axes. And then the developmental qualities. Can I understand the code? Does it appear habitable? Does it have unmanaged technical debt? Is it easy to change? Is it comprehensible? These three dimensions, if you think about them, whenever you're making a change to code, you're moving along one or more of these dimensions. But let's actually separate out the intentions. When we're talking about refactoring, Refactoring concretely is, I'm going to keep this one fixed. I'm going to keep the functionality axis fixed. I do not want this to change. This is behavior preserving. But I do want to change something about the developmental quality. I want to make this easier to add stuff to. That's my anticipation. That's where I'm heading. Yeah? And either that's because I'm in the wrong paradigm or the code is the wrong shape for the problem. The code itself might actually be good. I think we need to also take a step back and recognize we're not always, refactoring is not about bad code necessarily. It's about code that doesn't quite fit. It once was good, but guess what? History has got the better of it. Okay? We have a series of changes that we could not anticipate because, bizarrely enough, we cannot predict the future. So therefore, this code, the original formulation, the abstractions, the paradigms we chose, the technologies, the world has moved on. We need to make a change. The code was good, but it's not present tense, okay? So we focus on that. We want to change that. What happens to our operation? Well, it'd be nice if it didn't change, but we're saying basically performance could be the same in some aspects, could be worse, could be better. That's not the one we're focused on. By contrast, when we do optimization, it's kind of like a chiral version of this. It's a mirror image in one sense. Is what we're doing is also a functionality preserving transformation. When you optimize, you are trying to preserve the previous behavior. Yeah, it's kind of helpful not to introduce bugs. Otherwise, you find yourself in that awkward position of saying, yes, I did the optimization. Yeah, but it breaks. We've seen the logs. Yes, but it breaks really quickly. Yeah, or it breaks with less memory. It's just like, yes, we didn't actually want the whole crashing thing. So the idea is that it fits some of the same profile, but it's not identical. Here, so in other words, we keep one axis fixed, we make a positive movement along others. To be fair, there may be negative movement on this one as well. For example, we improve speed, but that may be a trade-off in terms of space. But the idea is I want to capture the idea of a specific intention. It's not your job to make the code worse when you optimize, but it may get more complex. It may, when we say it gets worse, it means more complex. A piece of code that has caching is more complex than an equivalent behavior without caching. Yeah, simply because there are more conditions and states you have to account for. So that, in other words, means more on me as a developer to account for. If I'm fixing bugs, then what we're doing is actually specifically trying to move up the functional axis. But we're doing so from a disadvantaged position. We promised you this much behavior, you actually got this much. Yeah, okay. It's a deficit. A bug is effectively a deficit on the functional axis. Whereas feature addition is, we're where we want to be, and now we're going to add more. Okay. Now, the reason I say this can be a helpful thinking model is it allows you to perhaps clarify your commits. Do not do as somebody I worked with many years ago, and I'm very sure that he is way beyond retired now, so will not be watching this online. All his check-in messages were kind of the same. Added some things, fixed some things, moved some code around. They were all identical. It's just like, yeah, that's not very helpful. And his name was John Smith, so it's suitably anonymous in both dimensions. Okay, so what we're going to do is we're going to add conjured items. We have one example, but I'm not going to stick to that. I see a lot of people, when they add this, they add it hard-coded to conjured manna cake. That's not what the requirements said. They said conjured items, okay? That's an example. Okay, don't hard-code it everywhere. So I'm going to add some tests. Guess what? Never trust a test you haven't seen fail. These fail miserably, every single one of them. Excellent. That's exactly what we want, okay? And then what we do is we take the code, we add, one condition, and we are done. There we go, that was easy. Yeah, and so that, if you like, is the essence of this whole approach. The idea of, if you added conjured items to the original code, you would have had to add it in a number of different places, undoubtedly introducing bugs you hadn't tracked. So the first thing is, you want to work with tests anyway. The other thing is, once we've now got this code into a fluid state and we've accepted the idea of change as normal, we are actually free to then actually try and explore the paradigm space. As it stands, the code's not bad. But this is the paper that introduced the word paradigms to software. 1978, Turing Award speech, published in 1979. Robert Floyd did a lot of work on compilers and correctness analysis in the 1960s onwards. The original given when then dates from Tony Hoare's precondition, operation, postcondition, known as a Hoare triple. Tony Hoare based his work on Robert Floyd's work, so that's where that comes from. There's a nice unity to all of this. He introduced the word paradigms, and from that point on, people just couldn't resist that word, and the word paradigm popped up everywhere and exploded onto the scene, particularly in the 1990s. But his key idea, I believe the current state of the art of computer programming reflects inadequacies in our stock of paradigms, in our knowledge of existing paradigms, in the way we teach programming paradigms, and in the way our programming languages support or fail to support the paradigms of their user communities. This was written in the late 70s. It's still kind of true. But importantly, what he's talking about is paradigms plural. He's not after the one true paradigm. And to be fair, if we look at the code, the dominant type is string. Perhaps that's a failing, but actually, if we look at what's going on, it really is a stringly type system, okay? There's nothing there that says you want to go about creating a class hierarchy. But there is something there that we can use. There is polymorphism that we can exploit. So if I go back here, I'm going to make a small change. I'm going to change all of those starts with and equals into regular expressions. Because why not? You know, life, we can make life more complex. Now, they're all very simple. You can actually do it with wildcard matching if you want to. What I'm now going to do is I'm going to recognize that what we are, this is a pattern matching thing. Basically, we've got it's a rule engine. There is a condition, we trigger some code to figure out the adjustment. Here's the condition under which we fire this. Like build systems. Build systems are declarative systems. Here is a rule. Oh, this file is older than that file. You're going to need this build rule. Okay? So in other words, we are just pattern matching. That's what's going on. It's just we have to wrap it in this very messy layer. So I'm going to take an idea from earlier, and I'm going to do this while the person who came and slapped me around the face for introducing complexity is in the other room. And I'm going to reframe quality adjustment. Quality adjustment is not a value, it's a thing that we do. It's a thing that it is the act of calculating. So now I have got lambdas all the way through. One of significance here is sulfurous. There is no quality. Literally null means for once in its life, null is actually doing the right job. There is no quality adjustment. It's like spoons, okay? There is no quality adjustment. And then we apply it. If there is a quality adjustment, we apply it. Okay, so this is not that much better. But what I'm going to do, I'm going to miss out some steps because, in the interest of time. But what we can do is we can then move that into a table. In other words, there is a table that tells you it's a rule engine. I've literally defined a rule engine. This is a declarative problem. It's not an imperative problem at all. First of all, we tackled it on its own terms. It's presented as a control flow problem. Let's refactor the control problem. Refactor it on its own terms before migrating it to another paradigm. At this point, we realize once you've got through that if-else if, you suddenly realize, there's not a lot of objectiness. Not at this stage. There could be if somebody added a bucket load more requirements. But that's not where we are. That's in a future that we have not yet encountered. So we don't need to generalize for it. So the idea here is that we are just trying to match and fire. So therefore, we're going to create a table. Turns out tables are surprisingly easy to read. So we've now got the code in two parts. I then run through this. And that's a bit messy. I could probably refactor that, but there's a number of things I can do. I'm just going to rely on the fact that a C# developer should be able to read link. If you're doing this in C++, then the chances are, the way that I normally do it is I normally use the STL. You can also switch to using ranges. The idea is I'm trying to do something very simple. Find me the first thing that matches. Thank you very much. You don't really need to write a loop for that and embed all the other stuff in. The idea of find me the first thing that matches is not a new one. You've probably written that a gazillion times. You don't need to write it again. That's why libraries exist. So the idea is I'm going to take advantage of that. And now we've got something that actually has a very different characteristic. We have finally abstracted. If you're not comfortable with that, that's fine, leave it at the previous stage. But if you were looking to feel for the paradigm that most closely expresses this code, then we are now somewhere in that region. It is a rule engine. Here is the rule. It's actually done on text matching. Perhaps there are different criteria. Perhaps requirements in future will invalidate that assumption. That's fine. We've got tests. We've got refactoring-oriented software engineering. It's not a problem to change stuff. You saw where we started. Trust me, any other paradigm change is going to be pretty easy. So the point there is, when we look at it, It's kind of in two parts. Here is the data definition. This is the nature of the Gilded Rose problem. There are things and there are rules of how to deal with them. Those things are matched based on strings. We have no other knowledge that tells us that that there is any other case. And we have simple rules firing off that. And then we have something that simply runs through that. When you need to add new items, you add to this, but it doesn't change the control flow. The control flow is now stable because it's just a lookup. That's all that's going on here. Now, this is kind of not a new idea. The late Fred Brooks observed this in the Mythical Man Month. Observed that representation is the essence of programming. Sometimes the strategic breakthrough will be a new algorithm. Much more often, strategic breakthrough will come from redoing the representation of the data or tables. This is where the heart of the program lies. So, in closing, there is this observation about architecture, inhabited sculpture. This is made about building architecture, but there's a certain truth to it in software. There is this quote from George Pentecost. If you go on the internet, you'll find various people have said this, apparently. Michelangelo, Abraham Lincoln, probably Einstein. But actually, it was George Pentecost, and the essay in question is The Angel in the Marble. There is a beautiful angel in that block of marble, and I'm going to find it. All I have to do is knock off the outside pieces of the marble and be very careful not to cut into the angel with my chisel. The good news is we can ignore this because we work with software. If you knock something into the chisel, if you chisel something incorrectly, you just undo. We have time travel. How cool is that? How many other professions have time travel as a convenience and a standard way of working? Yeah? So again, that's one of those ones, next time you're trying to explain to your family what it is you do, just say that you're a traveler in time and space, and they will leave you alone. The point about software is that it's soft. That's the whole point of all of this, and yet somehow we've created a profession where we've treated it as if it's something hard. In fact, I think my font is a little bit too soft. There you go. So when do we do this stuff? The whole point here is that this is not something we should wait to accumulate. The author, Annie Dillard, made this lovely observation. How we spend our days is, of course, how we spend our lives. This is something we do. You don't have maybe you need a crisis sprint of refactoring to kind of like retrieve knowledge and value from something. But the idea is you shouldn't rely on that strategy. You should basically, this is a thing we do always. I don't have a special day where I put all the semicolons in. I don't budget a day for putting curly brackets in. It's kind of like that's kind of part of the flow. We talk about continuous everything else, continuous deployment, continuous testing. So this is continuous, the refactoring approach. And the wisdom of Isabella Beaton, who wrote a book on household management in the 19th century, which actually lingered into the 20th century and informed the terrible cooking habits of a generation of students, at least until the 1950s or 1960s in this country, because she also had a bunch of recipes in there. If you've ever, so there's a whole lot of stuff there. She carefully wrapped up all her software advice in the metaphor of household management, and particularly the work on the kitchen. There is no work like early work. Clear as you go. Muddle makes more muddle. Not to wash plates and dishes soon after using makes more work. Because, as Hemingway said, the only kind of writing is rewriting. So, thank you very much. I hope that's been helpful, informative, aggravating, provocative, whatever. I'm going to be around drinking and talking. And feel free to ask me questions or give me cheap abuse, preferably cheap kind, not the expensive kind. I can't afford it. Thank you very much.